Hello. So we're working on 4.5 today. We're going to be discussing end behavior of rational functions. We've kind of already discussed this through playing, and today we're going to try to better develop that understanding, and we'll finalize it tomorrow in class. So today you're going to be kind of exploring. You will need to be using decimals quite a bit, so make sure you're prepared for that. And we'll be finishing up. So the other thing we're going to be working on is behavior of even and odd functions, not even and odd polynomials. So if you were in class on Thursday, we discussed this briefly, the difference between even and odd functions versus even and odd polynomials, and we'll talk more about it as we go. But we're going to start with end behavior of rational functions, and this is an exploration. So what I want you to be doing is read through the words. I'm going to read them to you, but as you continue into part one, there's a lot of words here, and we're going to think about what's going on. So when we did 4.1, which was called the gift, Marcus and Hannah were talking about the discussion regarding the end behavior of the parent function f of x equals 1 over x. And Marcus thought that end behavior of all functions was either going to positive or negative infinity, which is completely true for polynomials. But now we have this function, which Hannah noticed, that approached 0, which 1 over x, the ends both approach 0. As x becomes really big, the function becomes really, really small, and as x becomes really, really negative, or really small, the function also becomes 0. So does this always happen? And Marcus is like, sure, why not? All polynomial functions go to positive and negative infinity, so why wouldn't all rational functions do the same thing? So do you think Marcus is right? And we've looked at a lot of different graphs already, so make a decision based on that. Make a conjecture about the end behavior of rational functions is our goal here. So we're not going to do that right away, but we're going to think about various rational functions as we analyze the end behavior. So we're going to try to generalize patterns we've noticed. So the first thing we're going to do is I've given you 4 functions, and we have the parent, and then these other 3. Now, I want you to look at what's happening here. This one, the degrees of the numerator and denominator are equal. This one, the numerator is greater, and then this one, the numerator is also greater, meaning all 3 of these are, I forgot a word. Hang on a minute. So all 3 of these functions, as I was trying to remember the word, are improper fractions, and this one is proper. So what I want you to do is kind of think about what proper fractions do, and then improper. Now, there is a special reason why I chose these 3 functions. So this function where they're equal, we're going to play some games with equal degrees in numerator and denominator. Where the numerator is greater by a lot, notice there's 3 differences here, and this one is greater by just 1. And the greater by just 1 is very interesting, so we're going to spend some time with this. But they're equal, greater by a lot, or greater by 1. So let's jump over to decimals, and we'll see what we've got going on. And I need to move this. So sorry for bounciness in the screen. I don't know if I can adjust it. It doesn't look like I can. So here's 1 over x, which we've seen a couple of times. It's our parent. The ends are approaching 0. And this is a proper fraction. So what I want you to do is play some games and come up with some more proper fractions to test. So remember, proper fractions where the degree of the numerator is smaller than the degree of the denominator, so like x squared over x cubed, and so on. Of course, that's this, so make sure you put some other things on it. So you're going to create a function that is proper, and so like 1 over x squared, and see what happens to the end behavior. See if it changes when you add 2x, and you're going to get some weird things. Don't worry about what's going on in the middle. The middles are going to be weird, but just spend some time playing. So I want you to do at least 5 proper fractions and see if you can come up with what's going on. So pause the video now and do 5 proper fractions. I hope you had some fun. Write down what you noticed about all the proper fractions. They all have very similar end behaviors. So it's really important to me that you've kind of come up to some sort of conclusion We will talk about it as a class tomorrow, but I'm hoping you're coming up with something on your own. So I'm going to go ahead and turn this one off. And then we have the improper fractions, and there are 3 categories. We have their equal and what's happening to the ends as we go. So on this one, you'll notice that our ends seem to be approaching positive 1. And so I'd like you to do a lot where they're equal. So let's see if we can do, I don't know, another one. We'll have x raised to the second. Let's make this 3x squared over x squared. That's not good. Plus x, and see what's happening to that end behavior. And this time I want you to come up, you're going to want to do leading coefficients that are different. See what happens as you play some games with the leading coefficients. It's a little tricky what's going on here, and I want you to see if you can come up with something that's happening when the degrees match. Make sure you don't have, you need to have something in the denominator. Like you can just play games with changing the degrees here with this funky one I created. Try to do at least 5 again and see if you can come up with a conclusion. Remember, you should be not just working on your own, but talking to each other and working in groups and discussing what's going on as you play these games. So again, pause the video and see what you can come up with. Okay, so I hope you've had some fun. I'm going to go ahead and turn these off and get rid of these. And what did you discover? And again, we're going to talk about it tomorrow. So I'm wanting you to come up with something so that we can talk about it in class together. So the next improper fraction category we're going to talk about is much different. So where the numerator is much larger than the degree of the denominator. So if you look at this one, we have an asymptote at x equals 0, and we have the ends seem to be going to infinity. So this end is going off to positive infinity, that end is going off to negative infinity. So I'm going to go ahead and turn that one off and try another one. X to the third minus 6x divided by x. Now that one's not very helpful because of course I made a comment. So let's make this x minus 7. And it looks just polynomial, nothing crazy, and it probably just has a hole in it. I probably wasn't very careful. Zooming out to see if I can get something interesting. Yeah, I wasn't very careful, so let's go with x to the first. There you go. So I've got my asymptote. I needed to keep an asymptote in it. The other one didn't seem to have one at 1. And it actually probably did. I just didn't see it. You see this end going off to positive infinity. The other end also going off to positive infinity. What happens if I add a 4? Not much. Let's go with something even crazier on the top with a 7. So similar stuff. What's happening? So again, explore, come up with a bunch. You can use problems from our homework if you're having trouble coming up with equations. See what you come up with. Again, talk to your classmates, and I'll be back in just a minute. All right, so what did you discover? I'm so excited to talk to you about this tomorrow. I hope you're coming up with something interesting that's going on. We have our third category here, which is where the denominator is only bigger by 1. So we have this. So here it is. And you'll notice that, yeah, the ends are going off to infinity, which might have happened with h of x as well. But they're kind of doing something different. I'm just going to zoom way, 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 way out. And it looks just like an x, which it doesn't look anything like an x when I'm close. But you kind of see that we have a slanted line and then a vertical line. And those represent something important, and I'm hoping you can come up with it. So you're going to just do one bigger on the numerator. So I could do my numerator of x to the third minus 2x plus 1 over x, not x, I want x squared, and see what's happening with that one. Let me turn off this p and see what's happening with the other one. And again, if I zoom way, 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 way out, you can see a vertical line going up and then a soft slanted line. What happens if I have a number in front here? Does it change things? Well, it does, sort of, but I still have a slanted line, but now it's a little steeper. Okay. And what's happening? So I want you to play, see what you can come up with, and we will talk about this the next time I see you.